Hello friends, welcome to this fourth video on Laplace transform. This video will be exploring on one more property of Laplace transform given by Laplace of integrals. If we need to find Laplace of integral from 0 to t f of t dt, then just go for finding the Laplace of f of t and multiplying with 1 by s. So, if I have integral multiplied by 1 by s. That is going to be the rule over here. Come on, let us check how to apply this to problems. Let me find what is going to be Laplace of integral from 0 to t sin t divided by t. So what will happen now? This is nothing but whenever I find integral from 0 to t, I will have to multiply by s and then multiply by 1 by s and take Laplace to the remaining left out function. What is my left out function? It is sin t divided by t. So it is 1 by s Laplace of sin t by t. We saw in the previous property that whenever I have division by t, then the rule is integrate from s to infinity the Laplace of your f of t. What is your f of t? Now this becomes sin t with respect to ds. So it gives me 1 by s integral from s to infinity. What do we know about Laplace of sin t? It is 1 divided by s square plus 1, which has to be integrated with respect to ds. So it gives me 1 by s. What is ds divided by s square plus 1? We know that integral dx divided by x square plus a square is 1 by a tan inverse x by a. In place of x, we have it as s. In place of a, we have it as 1. So it is 1 by s times of 1 tan inverse of s by 1 with the limits from infinity to s. So this gives me 1 by s. Apply the upper limit. It becomes tan inverse infinity minus tan inverse s. What we know about tan inverse infinity? This is going to be equal to pi by 2 minus tan inverse s. What is 90 minus tan inverse of theta? It will be your cot inverse of theta. And what you have outside is 1 by s. So, the final answer will be 1 by s cot inverse of s. Can we apply it to one more problem and see? Come on. Problem number 2. Let us find what is the Laplace of integral from 0 to t. We will try to increase the complexity of the problem by combining one more function called as e power minus t sin t by t dt. Okay. So, in the previous problem, there was only sin t by t. But now there is only more quantity called as e power minus t. What does our e power minus t do? It shifts the operator by s from s plus a units. Okay. So, first we will try to apply the quantities one by one. First, when we see the integration, what is this integration to be replaced by? Integration has to be replaced by 1 by s and take Laplace to all the leftover quantity. What is the leftover quantity? It is nothing but e power minus t sin t divided by t. Now, the next step is applying exponential to my function. Let me consider this as one function. Apply exponential shift to it. So this will lead me to Laplace of sin t by t, and wherever you have s, inside this Laplace will be shifted by how many units? Since it is minus, it will be plus. A is going to be equal to 1. So it is shifted by 1 unit. Notice only the function of s inside this Laplace will be shifted, but this 1 by s which has already completed the action and outside will not be shifted. So this shift is applicable only for the terms of s inside this Laplace. So now the next stage 1 by s. Now I will have to go for the next value which is to be considered division by t. What does division by t say? I will have to integrate from s to infinity Laplace of the leftover quantity with respect to ds. And this answer which I get has to be shifted by s plus 1 unit. Now, let me move to the next stage. Integral from s to infinity. What do you know about Laplace of sine t? It is 1 divided by s square plus 1 into ds. And this shifts to s plus 1. As we know, integral ds by s square plus 1 is your tan inverse s. This has to be applied limit between infinity to s. And then finally shift it to s plus. So this gives me 1 by s tan inverse infinity minus tan inverse of s with s moving to s plus 1. So it gives me 1 by s times of tan inverse infinity is going to be y by 2. 90 minus theta will give me cot inverse of s with s moving to s plus 1. So now where is our s? Here is our s. So this s gets replaced as s plus 1 by the exponential operator. And what is outside already? We have an 1 by s. So this completes the action of all the three components 0 to t, e power minus t, division by t. So three rules which we saw as properties priorly got applied. Integral means replace it with 1 by s. Exponential means shift it by e units. Division by t means integrate from s to infinity. So apply all the three properties which we have learnt one after the other in a hierarchical way and try to get your answer. Thank you.